If x is 2z, y is 3z minus 1, and x is 40, what is the value of y? So 40 is going to be x, so if we take that, we have 2z, so z is 20. And then if we plug it into there, we have y is equal to 3 times 20 minus 1, so that's going to be 59. And I think that's it. What is the smallest two-digit positive integer that is a multiple of 6 but not a multiple of 4? So let's list the multiples of 6. Multiples of 6. So let's just list the first few. 6, 12, 18, 24, 30, and so on. I think that should be good enough. And then let's see which ones are multiples of 4. Oh, 2 digits. Oh, okay, so we can't count this one. It's got to be 2 digit. Okay, multiples of 4. Is this a multiple of 4? Yes. This is not. This, yes. This is no. And what do they want? They want the smallest. Okay, so I don't have to keep going. I just can choose that and just end the question. The integer 2022 is positive and has 4 digits. 3 of its digits are 2 and 1 of its digits is 0. What is the difference between the largest and smallest 4-digit integers that can be made using 3 2s and 1 0 as digits? Let's list them. We have 2022, 2202, 2220, and 0222. Now, immediately, hopefully, you can detect that that one is invalid because that is no longer a 4-digit number. If you put the 0 as the leading digit, it becomes invalid. So we're just working with these 3. Now, which one's the largest? I believe this one is the largest. And which one is the smallest? I think it's this one. So they want the difference between those two. The difference between the largest and the smallest. And that is 198. Total of n people were asked a question in a survey. Exactly 76% of the n people responded to yes, and exactly 24% of the n people responded no. What is the smallest possible value of n? Okay, n is going to be 0.76. N is yes, and 0.24 n is no. All right, so smallest possible. How would I know? So if it was 100, then this would be 76 and 24. I guess because it's people, it's got to be integers. So when you no longer get integers, I think that's the approach. So if I have this, if we started with 50, for example, it would still be integers, right? It'd be 36 and 12. How about if I started with 25? It would be 6 and... Hold on, did I do this right? Sorry, this should be 38, I believe. So that would be... Yeah, and I think that's it, because if I can't go down to 12.5, because that's not even a valid number, since we have to have whole numbers. And I think that's it. So the smallest, in order for everything to be an integer of n, is 25, and that would give 19 for yes and 6 for no. In the diagram, there are exactly 9 1x1 squares. What is the largest number of 1x1 squares that can be shaded so that no two shaded squares share a side? All right, let's see. If I shade that one, that one, and that one, then I have achieved that no two shaded squares share a side. And how many did I shade? 1, 2, 3, 4, 5, 6. So 6 is the answer. What is the value of x for this expression? Okay, so we get a common denominator, and that'd be 6x, and then that would be 6 plus 3 plus 2, I believe, and that's 1 over 12. So that is 11 over 6x is 1 over 12. Cross multiply, and we'll get 11 times 12 is 6x, and then divide through by 6, and we get 11 times 2 is x, so x is 22. There is exactly one isosceles triangle that has a side of length 10 and a side of length 22. What is the perimeter of this triangle? Okay, so let's see here. If the 10, 10, and 22 is like that, the perimeter would be 42. But here's the problem. This fails the triangle inequality because 10 plus 10 has to be greater than 22. But in this case, 10 plus 10 is not greater than 22, right? 10 plus 10 is 20. So it fails the triangle inequality. I'm sure you guys know about that. So the way I drew it is wrong. It's got to be drawn in another way. Let's see if I can draw it in another way and make it look realistic. 22, 22, and 10. That would be the proper way of drawing it. This, of course, would satisfy the triangle inequality, and therefore the perimeter would be 44 plus 10, 54 is the perimeter. Consider the lines with the equations y is equal to mx and y is equal to minus 2x plus 28, where m is some real number. The area enclosed by the two lines in the x-axis in the first quadrant is equal to 98. What is the value of m? Let's draw this. So we've got x-axis and y-axis, and let's see here. So we have y equals mx, so that's something like this. That's just going through the origin, right? So something like that. That's y equals mx. And then this guy, the y is equal to minus 2x plus 28. When x is 0, y would be 28. And then when y is 0, I think x will be 14. Yeah. So let's just say here. So that means that line, something like that. So what do we want? We want the area enclosed by the two lines and the x-axis. So we basically want this guy right here, that triangle. Okay. Not a problem. So the base is obviously 14. So the area of that triangle is 1/2 base times height. The base is 14. The height, of course, that's the top to bottom distance there. And that would basically be the y-coordinate of the intersection point of those two lines. So the intersection point of those two lines, these two lines up here, let's see here, that's going to be mx is equal to minus 2x plus 28, correct? So mx plus 2x is equal to 28. So x times m plus 2 is 28. So x is equal to 28 over m plus 2. And therefore y would be m times x, which is 28 over m plus 2. So 28m over m plus 2 is the height. So this guy right here, that is 28m over m plus 2. So stick that in here, 28m over m plus 2. And they told me the area is 98, so 98. 1/2 times 14 is 7. We got 28m over m plus 2. We can solve this here. So 98, let's see here, 98 is equal to 7 times 28 over m plus 2. Okay, cross multiply. 98 times m plus 2, and then 7 times 28 I believe is 126m. The 98 will go into the 196 twice, and then therefore 2 would be equal to m. Okay, that's it. M is equal to 2. A solid cube has a volume of 1000. A cube with volume 64 is removed from one corner of the cube. The resulting solid has a total of 9 faces. 3 large squares that were faces of the original cube, 3 of the original faces with the square removed from one corner, and 3 smaller squares. One of the smaller square faces is shaded. The ratio of the area of the shaded face to the surface area of the new solid is of the form 2 to x. What is the value of x? The volume is 1000. Now, if the side length was s, then s to the power 3 is 1000, so s is 10. So that means these are all 10s here. 10, 10, 10. And then the cube that's been cut out, that has a volume of 64. So if that has, say, a side length of whatever, n, so n cubed would be 64. So that n is 4. So this is a 4, 4, and 4 type scenario. Okay, so what are we being asked here? Surface area, ratio of the shaded face. So this face is just a 4 by 4. Shows shaded face, SF, over surface area of the new solid. Okay, so total surface area, TSA, total surface area. Okay, so well, what is it? Shaded face, SF. Shaded face, that's just a 4x4 square, so that's just going to be 16. So we can immediately just put 16 there. And then the total surface area, okay, that's going to take a little bit of work, but they're telling me that ratio is 2 over x. Okay, so let's talk about the total surface area. Okay, well, well, you have the 3 faces that were untouched that we don't see, right, on the other side. So that's 3 10 by 10 squares. And then we have these guys, the ones that kind of look like, you know, with a segment cut out. And that is going to be 10 by 10, subtracting from it a 4 by 4. Correct? And then we have the inner ones, and those are just 4 by 4. Yeah, 4 by 4. So and we have 3 of them. Oh wait, I gotta put 3 of them there. 3 of them, 4 by 4. And I think that's it. So let's see here, 16 over 300, and then 100 minus 16 is 84. So 3 times 84, 252. And then 3 times 4 times 4 is 16 times 3, which is 48. And that is equal to this 2 over x. Okay, that should be pretty straightforward math. 2 over x is 16 over 600. So that means 1200 is 16x, and therefore x is 1200 over 16, which I believe is 75. For some integers, the expression 8 times n minus 1 times n minus 1 over n minus 2 is equal to m. What is the sum of all possible values of m? Okay, well, n cannot equal 1 and n cannot equal 2, right? Because if it did, it would be undefined, because we can't have 0 in the denominator. So that expression n minus 1 over n minus 1 times n minus 2, the n minus 1s would cancel, so we're just left with 8 over n minus 2. Okay, so let's see here. This is an integer. So the only way that can be an integer is if n minus 2 is equal to some factor of 8. And they don't say anything about positive or negative, so it could be positive or negative. So n minus 2 could be plus or minus 8, could be plus or minus 4, plus or minus 2, or plus or minus 1. Is that right? Yeah. So, but we got to keep this in mind. Now, n cannot equal 2, and we don't need to worry about that, but n cannot equal 1, because if it did equal 1, it would be negative 1. So of these, the only ones we can use are the plus or minus 8, the plus or minus 4, the plus or minus 2, and if n was 1, that would be 1 minus 2 is negative 1, so negative 1 cannot be used, so we can only use both positive 1. Okay, so then if this is n minus 2, if we plug it back into there, 8 over those, so 8 over n minus 2, those would give us the following values: plus or minus 1, plus or minus 2, plus or minus 4, and 8. And then we just have to, these are basically the values of m. So we have to add up all these values. So it'll be 1 minus 1, 2 minus 2, 4 minus 4, and 8. And those all just come down to 8. A total of $425 was invested in 3 different accounts, account A, B, and C. After 1 year, the amount in A had increased by 5%, in B by 8%, and C by 10%. The increase in dollars was the same in each of the 3 accounts. How much money was originally invested in account C? Account A, account B, and account C. So after, 1 year? Yeah. We have 1.05A, 1.08B, and 1.10C. That's basically the math. But they also tell me that these amounts that it increased by are all equal in terms of their value, dollar value. And percentage, obviously, they're different, but if you were to figure out the actual dollar value, they'd be equal. So if I multiply through by 100, make this math easy, it'd be 5a is 8b is equal to 10c. And then we also know that the original value was 425. So that means that a plus b plus c is 425. So I think I can do this pretty easily because I have three variables. Yeah, but I have three equations though. Yeah, I can make three equations. Okay, shouldn't be too bad. So what am I trying to solve here for c? Okay, so I got to get everything in terms of c. So let's get a in terms of c. 5a is equal to 10c. So that means a is equal to 2c. Okay, so put that in there, 2c. And then let's get b in terms of c. 8b is equal to 10c, so b would be 10c over 8, which is 5c over 4. So that's going to be 5c over 4. And then c is already in terms of c, of course. And there we go, 425. So this can be easily solved. So it'll be 3c. What's 5 over 4? 1.25. So 4.25. C is 425. Oh, okay, that's easy. So c is 100. There we go. All the points on the line with the equation y is equal to 3x plus 6 are translated up 3 units, then translated left 4, and then reflected in the line with the equation y equals x. Determine the y-intercept of the resulting line. Okay. Well, let's see here. So let's graph the original. So y is equal to 3x plus 6, right? So when x is 0, y would be 6. So when x is 0, y would be 6. That's 1 point on the line. And then when y is 0, x would be negative 2, I believe. So that's another point, negative 2, 0. And then, of course, you join them. So that's the line. Oh, that's a terrible line. Let's see if I can draw it straight. Well, okay, you guys get the point. Okay, so now let's talk about what they're actually doing. Translated up 3 units. So that basically means what? That the y-coordinate goes up by 3. So this would go from 0, 6 to 0, 9. And this would go from -2 to -2, 3, correct? Then translated left 4 units. So that means the x-coordinate is going left 4. So we got to subtract 4 from the x-coordinate. So that would mean this is going to -4 and then 9. And this would be -6 and 3. And then it's reflected in the line y equals x. That basically means that the x and y coordinates are switched. So it'd be 9 minus 4, and that would be 3 minus 6. Yep. So these are the 2 new points on the new line, and then they want us to figure out the y-intercept. So we got to figure out the equation of the line first. So the slope would be rise over run, -4 minus -6, so it'd be -4 plus 6, and then 9 minus 3. That's a third. And then, therefore, the equation is 1/3 x plus b. To figure out b, let's substitute one of those points. -6 is equal to 1/3 times 3 plus b. So b is -7. Therefore, that equation is y is equal to x over 3 minus 7. The y-intercept would be when x is 0. When x is 0, y would be -7. A list of integers consists of n plus 1 ones, n plus 2 twos, n plus 3 threes, n plus 4 fours, and n plus 5 fives. The average mean of the list is 19 over 6. What is m? So we have a whole bunch of ones, and they're telling us that it's m plus 1. Like, for example, if m was 7, it would be 8 of these. There's 8 ones. And similarly, a whole bunch of twos, and they're telling me there's m plus 2 of those guys, and so on. You guys get the point. M plus 3, a whole bunch of 4s, we don't know how many, but they tell us it's m plus 4, and a whole bunch of 5s, and that's m plus 5. So the average, you guys know how to figure out averages, right? So you take how many there are, and you multiply by the value of each, and then how many there are, and multiply by the value of each, and so on. And then this would be m plus 3 times 3, m plus 4 times 4, and m plus 5 times 5. And all over the total, which would be m plus 1 plus m plus 2 plus m plus 3 plus m plus 4 plus m plus 5. Got it? Okay, so you guys can do that algebra. It's fairly straight. Oh, it all equals this. Forgot about that. That's all equal to 19 over 6, so don't forget that, of course. So when you do this algebra, it'll be 15m plus 55 over 5m plus 15. And that's equal to 19 over 6. So if you divide top and bottom by 5, you get 3m plus 11 over m plus 3 is equal to 19 over 6. And then cross multiply, and you will get 19m plus 57 and 18m plus 66. And therefore m would be 9. And Bohan, Shay, Devi, and Eden each ordered a different meal at a restaurant and asked for their own bill. Although the correct 5 bills arrived at the table, none of them were given to the correct person. If the following 4 statements are true, who was given the bill for Bohan's meal? Shay and Eden ordered meals with the same cost. Devi's bill was given to the same person whose bill was given to Devi. And Bohan and Eden were each given a bill for less money than the meal they ordered, and his bill was given to Shay. Let's experiment and see what happens. I think that's the only way. So first we start off with A, B, C, D, and E. And then I'll just let those letters represent not only the person's name, but also the amount. And then in the second column, what they actually got, the bill that they actually got. Okay, so let's experiment here. Let's see what happens. If I'm wrong, I'll try something else. Okay, so we are only told one piece of helpful information, and that's this one, that Anne's bill was given to Shay. So Shay actually got A. That's all we know. Okay, so where do I go from here? All right, so let's say this one here, that we're going to work with this one here, Devi. Her bill was given to somebody, and that bill was given to Devi. So I don't know who that is, so that's what I'm going to experiment with. Let's try, well, it can't be A because A has already been assigned, so let's try B then. So that means that D got B's bill and B got D's bill. Okay, so I'm just working through here. Now there's only 2 people left, and nobody got their own bill. So that means A has to have gotten E, and E must have gotten A. Okay, but that falls apart, right? Because A has now been assigned to 2 people. Right, there's an A here and A here. So that fell apart. Okay, not a problem. Like I said, if we fail, we try again. So let's try again here. We're doing the same thing, but this time we're going to try a different assignment. Because the only thing we know is the C is given A. Anne's bill is given to Shay. That's the only thing we know. So Shay gets A. Now let's go back to this one. This point right here. Devi is given somebody's bill, like it is exchanged. So we can't put A because A has already been assigned to C. We tried B, that failed. Who do you want to try then? Let's try, well, it can't be C because C's already been assigned, and the only other choice is E. So D is given E and E is given D, like that. Okay, so then we have to figure out, well, A and B are the only ones left, so they obviously, let me think about this. So we are figure out how to allot what goes to A and B. Now, A can't get A, and B can't get A's already been allotted. So B the only place B can go is here, because B can't get B. So the only letter left is what? C, right? So C goes here. I think that's the only way of doing it. Yeah, I think that's the only way. So that basically means, what are they actually asking us? Who was given Bohan's bill? So who was given B? Anne was given B. So Anne is the answer. And I encourage you to kind of do this on your own, experiment with it based on these rules, and I'm pretty sure you get the same result. The points PQR are the vertices of a triangle. PQR is 90 degrees. What is the value of x? Let's draw the graph here. It's going to be something like this. I'm not entirely sure. Well, this is the 90 degrees. So the P is 2, 0. And then the Q is 11 minus 3. And the R is x3. So what we'll do is, since this line is perpendicular to that line, their slopes will be negative reciprocals, meaning one slope is m, the other slope would be negative 1 over m, and their product would be negative 1, right? Yeah, the slopes are negative reciprocals of two lines that are perpendicular. Yeah. Okay, so let's figure out the slope of the first line. So PQ, slope of PQ. So that would be minus 3 minus 0 over 11 minus 2. And that's going to be 1/3 negative. And the slope of the other guy, that's QR. That's 3 plus 3 over x minus 11. So that's 6 over x minus 11. And therefore, these two slopes are negative reciprocals. So basically what that means is that when you multiply them together, they give negative 1. Yeah. So 6 times x minus 11 times this guy would be negative 1. So 6 over x minus 11 would be 3, I guess, right? So that would mean that 6 equals 3x minus 33, and therefore 39 is equal to 3x, and therefore x is equal to 13. X is 13. The equation x squared minus 7x plus k is 0 has solutions x equals 3 and x equals a. The equation x squared minus 8x plus k plus 1 is 0 has solutions x equals b and x equals c. What is the value of a plus bc? X squared minus 7x plus k is 0. That, they're telling me, has solutions x equals 3 and x equals a. Okay. And then the other one, x squared minus 8x plus k plus 1, that has solutions x equals b and x equals c. Okay, that doesn't help me. So let's concentrate on this guy first. If you substitute, sorry, a, this is an a, it shouldn't be a 0. If you substitute the 3, we get 9 minus 21 plus k is 0. So k is actually equal to 12, and that's very helpful. And then let's substitute that back into the equation. So x squared minus 7x plus 12 is 0, and let's factor. So we got 4, 3, negative, negative. So x is 4 and x is 3. So the 3 they gave us, and I guess that a is 4. So a is equal to 4. Okay. And I guess we're doing the same thing over here. X squared minus 8x, k is 12, so that's going to be k plus 1. Does this factor? Unfortunately does not, so we've got to use the dreaded quadratic. 8 plus or minus 8 squared minus 4 times 13 over 2. And therefore this is going to be 8 plus or minus 64 minus 52, which is 12. Yeah. Root 12 over 2, and then that reduces to 4 plus or minus root 3. Okay, so that means that first one we can call it 4 plus root 3, and the second one we can call 4 minus root 3. Okay, so now we can do this A plus BC. A plus BC. So A is 4, and then BC Well, b is 4 plus root 3, and c is 4 minus root 3. So it's going to be 4 plus 16 minus 3, and that is 17. Yeah. The functions f at x and g at x are defined by f at x is 9 to the power of x, and g at x is equal to the log of 9x to the base 3. The real number x satisfies g at f at x is equal to f at g at 2. What is the value of x? All right, so let's do this one step at a time. Let's do the first one, g at f at x, and see what happens. So that's going to be g at 9 to the power of x, and that's going to be the log of 9 times 9 to the power of x to the base 3. And then combining that, that's going to be 9, 1 plus x to the base 3. We can put, let me change that 9 to 3 to the power of 2. And then therefore that's going to be the log of 3 to the base 3, 2 plus 2x. And then the 2 plus 2x comes out front using the basic log rules. Log of 3 to the base 3. And then log 3 to the base 3, that's just 1. So that's just going to be 2 plus 2x. So now let's go to the other guy. So that's f at g at 2, like that. And that is going to be f at log of, what is it going to be? Base is 3. Where am I? Where is this g? Oh, okay, 9 times 2. I got it. Okay. So that's basically the f of log of 18 to the base 3. And then now we can use the function 9 to the power of log 18 to the base 3. And then let's switch that to a 3 power. So that's going to be 3 to the log of 18 to the base 3 all squared. And then there's a log rule. Some of you may remember, some of you may not. And that log rule is that if you have a to the log of k to the base a, that is equal to k. So if you use that, that's just going to be 18. And then therefore that's 324. So now that equals that, so that basically means that 2 plus 2x is equal to 324. So that means that 2x is equal to 322, and therefore x is 161. The real number theta is an angle measure in degrees that satisfies theta between 0 and 360 and 2002 to the power of 2 sine squared theta minus 3 sine theta plus 1 is 1. What the sum of the possible values of theta is k. What is the value of k? All right. Well, this to some power is 1. So that means that power must be 0, right? Because anything to the 0 power would be 1. So that 2 sine squared theta minus 3 sine theta plus 1, that exponent is actually equal to 0. Okay, so that's pretty good. We can factor this pretty nicely, I believe. This will be 2 sine theta, negative 1, negative 1. Yeah, so that basically means that either sine theta is 1 or sine theta is equal to half. Okay, so let's draw the graph. I always like drawing the graph. It helps me out. And it's between 0 and 360. So there's 0, there's 360. And let's see, where does it equal 1? The first guy. Well, 1 is the value, the highest value, and that happens when 90 degrees is the value for theta. This is theta, and this is sine theta. And then when is it a half? Well, a half is approximately here. So it'll happen here and here. And of course, I know those. You can just use a calculator, but I've done this so many times. I know that's 30, and that's 150. Okay, so then that means that the values of theta are 30, 90, and 150. And they want me to figure out the sum of the possible values. Okay, the sum would be 30 plus 90 plus 150. So that's what? 270? The vertices of a 3 by 1 by 1 rectangular prism are A through H, so that AE, BF, CG, and DH are the edges of length 3. Point I and J are on AE, so that AI is equal to IJ is equal to JE is equal to 1. And similarly, so on. For every pair of the 16 points A through P, Maria computes the distance between them and lists the 120 distances. How many of these 120 distances are equal to root 2? Well, how do they get 120? Well, there's 16 points, right? So if you have 2 points, there's 16 possible choices for the first point and 15 remaining choices for the second point. And then that's 240, I believe. But each point has been double counted, like BC is the same as CB. So you got to take that 240 and divide by 2. And when you do, you get that 120. And that's how they got that 120. Then they're saying, how many of those 120 have a distance of root 2? Okay. All right, so that's going to be a little bit of discussion here. But I got to keep this diagram in the picture. Let's just start with A. And let's see, how do I get root 2 here? Root 2, if I look at a face, right? 1, 1, 1, 1. If this is A, B, C, and D, I think the diagonal would be root 2, right? Let's see here. If I draw a diagonal, AC squared would be 1 squared plus 1 squared, and therefore AC would be root 2. Okay, so a diagonal of a square that has side length 1. All right, so A can be paired with what? C to give a distance of root 2. Anything else? AC, AK? I don't want to draw the line on the diagram and make it too messy. And AO, I believe. Is there anything else? From A, I mean. I don't think so. Because all the other ones would be, like A to B would be 1, and then A to J would be 2, A to M would be, oh boy, I don't even know. You'd have to draw a 3D diagram. But I'm pretty sure these are the only ones. And very similarly, for B, it would be the same 3. It would be also 3 different ones. Let's see if I can write them. BD, BM, and BI. Let's see here. BD, BM, and BI, yeah. So similarly for C, D, E, F, G, and H. Now, notice these are just the corners. I'm just concentrating on the corners because they behave in the same way. And each of them will have 3. So since there's 1, 2, 3, 4, 5, 6, 7, 8 corners, and each of them has 3, there's a total of 24 that will have a distance of root 2. Yeah. Okay. I'm pretty sure that is correct. So let's move on now. I want to keep the diagram in the screen, so that's why I can't move this up too much. Now let's concentrate on the other guys. The other guys, well, whatever you want to call them, they're not corners, they're the other ones. So we're talking about these guys here. So there's 8 of those, right? Yeah. So we've got K, L, M, N, O, P. Oh, wait, I forgot the I and the J. Yeah, okay, well, there's 8 of those. Now, let's see how many of those you can make a root 2 distance. Let's start with the K. So for K, K to A would do it. K to C, K to O, K to N, and I believe K to J. So K to A, yes, KC, KO, yes, KN, and KJ. Yeah, so that's 5 for K. And then similarly, all the other ones would behave the same because they're pretty much the same in terms of their location style. So since there are 8 of them, there's going to be 8 times 5 of these guys, so 40. So this 24 and this 40 is 64. But It's a good thing I did this. That reminds me, this double counts. So you have to divide by 2. Why does it double count? Like, because here you have AC, right? But then you're going to have CA here. I didn't actually make that list. I didn't make the full list. So for every one, you're going to list it twice. So that's 64 double counts. So you have to divide by 2. And therefore, the actual unique number is 32. In the diagram, the circle has radius √5. And triangle ABCD and CD are on the circle. A and B are outside the circle. AB is tangent to the circle. What is the area of ABCD if AB is equal to 4AD? Okay, so let AD equal x, and then AB would be 4x. And then since that dotted line cuts it in half, this will be 2x and that will be 2x. And let's just label that something, or do we even need to? Nah, let's not label it. I don't want to make an unnecessary labeling. Okay, so let's draw a couple lines here. The first line is from the center of the circle to there, and I think that should be it. I don't think I need any other lines, so let's keep it simple. And now let's talk about this. So if that from there to there is 2x, and that means this from there to there is 2x, that green line is the radius, so that's √5. That dotted dashed line is also √5, but from top to bottom it's x. So this right here, that's going to be the radius minus that x. Okay, and then this is a right angle the way it's been drawn. So therefore that triangle we can use to make a Pythagorean relationship. So √5 minus x squared plus 2x squared is equal to √5 all squared. So let's do this. So we got 5 minus 2 √5x plus x squared plus 4x squared is equal to 5. So let's see here, 5x squared minus 2 √5x is equal to 0. So divide through by x, and that'll be 5x minus 2 √5. So therefore, this would be 0. So 5x would be equal to 2 √5. So x is equal to 2 √5 over 5. And then what are they asking us for? ABCD, the area of ABCD. Well, ABCD is a rectangle, so the area would be x times 4x, right? So 5x squared. Yeah, 5x squared. Okay, so x we got was 2 √5 over 5. So we'll square that. And therefore, hold on. What am I doing here? Sorry about that. This should be a 4. I don't know what happened there. I'm thinking of 5. There's so many 5s in here, I just got confused. All right, so we got 4, and that's going to be 4 times 5 over 25. Let me just make sure I did that right and didn't make any more mistakes. And then therefore, that's going to be 16 over 5, I believe. A square piece of paper ABCD is white on one side and gray on the other side. Initially, the paper is flat on the table with the gray side down. Point E is on BC so that when the paper is folded along AE, B lands on diagonal AC. Similarly, point F is on DC so that when the paper is folded along AF, D lands on AC. After these folds, the resulting shape is a kite, AECF. What fraction of the area of AECF is gray? Let's see here. I don't need to draw too many lines. I just want to draw one from F to E in that diagram, and I think everything else should be sufficient. Okay, so then let's start labeling this. Hopefully not too much labeling involved. Let's see here. I'll just call it Y, the side length of the square. And then that dashed line from A to C, I'll call D as the diagonal. So AC I'll call D, since that's D for diagonal. And where do I go from here? Okay, so they want the ratio of that gray area to the total area of AECF. Okay. All right. Well, the gray area is going to be 1/2 base times height, right? So let me give him a little bit more space here. 1/2 base times height. Now I've got to label this now. How do I label this? Well, let's just call this x and x, those distances. And then since it lands AB, right? When you fold it, it lands exactly onto there. So that means that this, from here to here, from A to there, that's also y. Yeah, that's the only way it can land. Say B ends up here. No, just call it B prime. See, this B, when it's folded, it lands here. So that means that those two distances must be the same. So therefore, 1/2 base, the base would be 2x, since this is x, and this is x, and then this is y, and the height would be y. Okay, I'm pretty confident about that. Now let's talk about AECF. AECF. Okay. Well, if I extend that line there, AECF is two triangles, right? Yeah, so 2 times 1/2 base times height. And we can call this as one of the triangles. So the base looks to me that all the way from A to C, and I've called that D. And then the height is B to E, or B prime to E, I should say. So that's x. So that's just basically dx. So that goes there. Okay, so this is xy over dx, and then for y over d. Oh, it's still got two variables though. Oh, but I think I can get d in terms of y, right? Because let me just draw that again, because it's gotten a little bit messy. We had a square, and the square had sides y, and the diagonal of called d. Yeah, I can definitely get y in terms of d because it's Pythagoras. So d squared is equal to y squared plus y squared. D squared equals 2y squared. D is equal to root 2y. Okay, there you go. So y over root 2y, and therefore that'd be 1 over root 2. And that is the ratio or fraction that they're asking for. The integers x, y, z, and p satisfy the equation x squared plus xz minus xy minus yz is equal to negative p. Given that p is prime, what is the value of the absolute value of y plus z in terms of p? Your answer should refer to the variable p so that it works for every prime number p. All right, so let's take this equation and let's see what we can do with it. Let's factor out an x plus z. Let's factor out a y, and we get x plus z. Okay, so that means we can go x plus z and then x minus y. Okay, now p is a prime number, right? So the only way this works is if one of these is a 1 and the other one is a prime, or one of them is p, the other one is prime, or negative 1 and negative p. That will also work. Yeah, I think that's the only way that's going to work. Okay, so where do I go from here? What do they want? They want the absolute value of y plus z. All right. Well, one thing I noticed is that if you took this guy and added to that guy, you get actually, what do you get? X plus z, x minus y. I think this needed to be modified first before I made this table. Yeah. Let me see here. Let me do this again. let's move this up here. If I have multiply through by -1 here, that would make it a little bit better. So that would be p, and then it would be x plus z, and then this would flip to y minus x. Yeah, that'd be better. Yeah, and then therefore this could be 1 in p, or p in 1, or -1, -p, -p, or -1. Now this is valid. So sorry about that. I think this is no good. This is good. Okay, I think that works. Now, if you notice what they're asking us, they want to figure out this absolute value of y plus z. But one thing I notice is that if you take this and add them, right, if you take x plus z and add it to y minus x, you actually get y plus z. So if you take the sum, you get y plus z. And similarly, if you take this sum, it'll be 1 plus p, p plus 1, -1 minus p, -p minus 1. See, I'm doing the same thing. So therefore, if I take the absolute value of those, it'll be 1 plus p, p plus 1. Absolute value of this would be p plus 1 and p plus 1. If you're not convinced, just take -1, -p, make the absolute value, right? It would be -1 times 1 plus p, absolute value, and it would be 1 plus p, like that. And yeah, that's it. So since all of these are 1 plus p, the only possible value for that absolute value of y plus z is 1 plus p. Riley has 64 cubes with dimensions 1 times 1 times 1. Each cube has its 6 faces labeled with a 2 on 2 opposite faces and 1 on each of its other 4 faces. The 64 cubes are arranged to build a 4 by 4 by 4 cube. Riley determines the total number of, on the outside of the cube, how many different possibilities are there for this total. So let's draw a cube. And let's see what we can figure out. So we have to break this up into 4 by 4 like this. So we got 4, 1, 2, 3, and so like this, right? Okay. So now there's going to be 3 styles. I guess there's going to be the corners. So these are the corners, the C guys. And then you're going to have the sides. I guess I just call them sides. So these are the sides. These are the sides. And then we'll have what I'll call the middle. The middle ones. So the middle ones are these guys. Okay. So now let's talk about what happens with each. With the corners, how many corner cubes are there? There's 8, right? And each of them has 3 faces. So there's 24 faces in total. Sides, 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3, 24 sides. And each of them has 2 faces. So that's going to be 48. And in the middle, there's 4 times 6, so 24. And each of them just has 1 face. So that's 24. So let's see here. If I add up these guys, it's 96. Is that 96? 96. Is that consistent? 16 times 6. Yeah, that is consistent with what I should have gotten. Okay, good. So I'm on the right track here. Now we got to figure out the sums of the numbers. So for the corners, let's see. Let's go back and read the question here. Each cube has its 6 faces labeled with a 2 on 2 opposite faces. That's a very key point here. Okay, so let me just draw a little cube here. So if this is a 2, the other 2 would be opposite, so it would be at the bottom. You got it? So there's the only way that the cube could ever be made is in terms of the corner faces, is a 2, 1, 1 scenario. You can never have 2, 2 because the 2 is opposite. Okay, that's really important. So then the corner is always a 2, 1, 1. So the sum for the corner would be a 4. Yeah. So since there's 8 corners, the total sum for each is 4, so 8 times 4, which is 32. Okay. Now let's turn our attention to the sides. The sides, okay, we got a couple possibilities there. We could have, if you have like that, you could have a 1, 2, or you could have a 1, 1. You can't have 2, 2 because the 2's have to be on opposite. So the sum would be either 3 or 2. And how many sides are there? There's 24, right? So the totals, the sums, hold on. Yeah, that was the sum. So the sum could be either 3 or 2. So the total sum is either 24 times 3, which is 72, or 24 times 2, which is 48. So, or. And then finally the middle guys, well, that could have either a 1 or a 2 on it. So this, how many others? 24, right? So we have 24 times 1, which is 24, or 24 times 2, which is 48. Okay. So I guess now we have to figure out the possible sums. So the lowest and the highest. Well, for the corners, it's fixed at 32. The lowest for the side is 48, and the lowest for the middle is 24. So that is 80 plus 24, so 104. And then for the highest, the corner is fixed at 32, the side is 72, and the middle is 48. So that would be 80, but 152. So we could have every possible value from 104 to 152 inclusive. So what are they asking for? How many different? Well, how many different basically are all the values between 104 and 152, and that would be a total of 49 values. It'd be 152 minus 103. Jane places the integers 1 through 9 in the 9 cells of the 3 by 3 grid. The sum of the 3 integers in a row are called a row sum, and the product of the 3 integers in a column is called a column product. After Jane arranges the integers, the following properties hold. Each integer is used only once. The integer 1 is in the leftmost cell of the second row. Integer 8 is in the center. 3 rows are equal. And the largest column product and the smallest column product differ by at most 40. Determine all possible values for the largest column product. So let's work through this and let's see. Let's draw a little grid here. So 1 goes here, 8 goes here. That's given here and here. So that's the first thing I'll put in. And then if this is the sum of the row 1, sum of row 2, sum of row 3, row 1 plus row 2 plus row 3 would be equal to the sum of all the numbers from 1 through 9. 1 plus 2 plus 3 all the way till 9. And we know that's 45. Now row 1, row 2, and row 3 are all equal according to that. So this basically means that R1 is equal R1 plus R1 plus R1, since row 2 and row 3 are the same as R1. So this basically means that 3R1 is equal to 45. So R1 is 15. So is R2, and so is R3. So that's good, because now we can easily figure out what goes into the last of the boxes in the second row. That would have to be a 6. So because the sum is got to be 15. Okay, so let's make a list here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've already used up the 1, the 8, and I've used up the 6. Okay, so far so good. Now let's figure out, how do I put the other numbers? Let's experiment now. So if I use this 2, I've got to make it so that the other two numbers add up to 15, right? So if I use a 3 for the next number, that would mean the next number will have to be 10. There's no 10. How about if I used a 4? Then that would mean the next number would have to be a 9. There is a 9. Okay, so that works. Let's keep experimenting. If I were to use a 2 and a 5, the next number would have to be an 8, but the 8's already been used. 2 and a 7, that would mean the next number would have to be 6, and the 6 is already used. So 2, 4, 9 is the only way. And therefore, the final row would be a 3, 5, 7 type thing. Not necessarily in that order, but those digits. Got it? Okay, so 2, 4, 9, 3, 5, 7. Okay, so let's see what happens. So we got 2, 4, 9, 2, 9, 4. The different ways of arranging those three numbers. 4, 9, 2, 9, 2, 4, 9, 4, 2. And then the middle one, that's always 1, 8, 6. So that's pretty straightforward there. Okay, then the final row I'll leave for now. Just, I got to talk about this first. Okay, so let's take this into consideration now. Okay, so we have to now concentrate on this rule here. This is a very important rule, that the column products, the biggest one and the smallest one, can't be more than 40 in terms of their difference. Okay, so let's see. The 9 and the 6, this guy, we have to now put in 3, 5, 7, right? So we don't want it to be too big. So with the differences. So the 9 and the 6, since those are the two biggest numbers in terms of the other columns, we want to put in a number that's smallest. So the smallest number of the 3, 5, 7 is a 3. So let's put that 3 there. And if I do that product, 9 times 6 times 3 is 162. Now this guy, that has just a 2 and a 1. So the maximum I can make that product is if I put a 7 there, that's 14. So as you can see, this and this already differ by much more than 40. And the maximum they can differ by is 40. So that falls apart. So let's see here. Same kind of story. The 9 and the 8, I want that as small as possible, so let's put a 3 there. And then the 2 and the 1, let's see what's the maximum I could get it is 7. So this will be 14, and this becomes 216, I believe. Hold on. Yeah, so again, 216 and 14 differ by much more than 40, so that falls apart. And then you do the same kind of thing there, same kind of thing there, and you'll eventually find that the only ones that actually could abide by that rule are these guys. Yeah, because these two will also fall apart. And I'll let you guys do that. I'm sure you can. So now we've narrowed it down to just these two. So again, the 924, 186. And then we have the 942 and the 186. So these are our final candidates here. And since we have to put 357, right? These guys, there's not that many of them, so we can just sort of do it manually. And let's see what happens. So 924, 186, 924, 186. Okay, so then now let's put in the 357. So we got 735 or 753. We got 573 or 537, 375 or 357. Okay, and then you look at the column products. So it'll be 63, 48, and 120. Is this a problem? Does the largest and the biggest column product differ by 40 or more, and the answer is yes. So this falls apart. The next one, you'll see it's 63, 80, and 72. This one actually works. So we'll keep this one, and they will actually want you to find the largest column product. So the largest column product is this one in arrangement that works and fulfills all our conditions. And similarly, this one is 45, the column products, 112 and 72, and I think that falls apart. This one is 45, 48, and 168. That falls apart. 27, 112, and 120. That also does not work. 27, 80, and 168. That also does not work. So far we only got one, that lone 80. Okay, and similarly, you guys can do the other ones. I'm sure you can do it. I'll help you out with a couple of these. You're just going to do the same thing, right? 942, 186. There's going to be 6 of them. And you will fill in the arrangements of the 735. So whatever, 537, 573, 357, 375, 735, 753, like that, right? And then you look at all the columns. So for example, this one was 45, 96, and 84. This actually works. It abides by the rules, and the largest of these would be this guy. And then I'll let you do all the other ones. You guys can do that. All you have to do is just figure out the column products and see if it abides by that rule that the largest and smallest differ by at most 40. And you'll see that most of them fall apart. And therefore, the only valid ones are the 80 and the 96, the 2 that I circled. So those are the 2 answers. Tetrahedron ABCD has base ABC. Point E is the midpoint of AB. F is on AD, so that FD is equal to 2AF. G is on BD, so that GD is 2BG. H is on CD, so that H is 2CH. Point M is the midpoint of FG. Point P is the point of intersection of the line segments E, H, and CM. What is the ratio of the volume of tetrahedron EBCP to the volume of tetrahedron ABCD? So eventually they want you to figure out EBCP over ABCD. Now there's 2 important facts that need to be, I guess, proven or figured out, and that helps you solve this eventual ratio. So the fact 1 is that the EBCP, that tetrahedron, it has the base EBC, right? EBC is its base. So the height of that is basically going from the base up to P. So this fact is that the heights are in the ratio 1 over 5. So if you have, let's say, the height from the base to P, so the ratio of the heights, I guess, ratio of heights. So if you have the height from the base to P, and if that's like from the base to P, and if it's compared to the base, because the bases are the same, right? They're on the same plane. The base to D, which is the big one, that would be a ratio of 1 to 5. And I'll show the proof at the end. But I first wanted to establish that fact, or at least state the fact. The second fact, if you look at this diagram, MD, the distance from M to D, is equal to 2 of the distance from E to M. So what that makes me think is that they're saying that D to E, if you drew a line from D to E, all those points are on that same line. And therefore, the distance from M to D is 2 times the distance from E to M. So that's another fact that I will show the proof of later on. But if these two facts are established, it makes the question actually much more easier to solve. So here we go with the actual solving of the question. So the first thing I want to do is sort of draw a little diagram, kind of like a side view. And first I'll label it, and then I'll explain what it is. So we got D up at the top, this D right here. And then we have P here, this P. And then going to draw these perpendicular lines. And this is sort of representing the base. So I'm showing you sort of from a side angle. Let's label these L, V, and K, whatever. Now, what I'm going to do is sort of show you a different angle, kind of like a, well, I'll just draw it and then you can see how it's a different angle. So this is now a different angle of the same kind of thing, but now the base is still at the bottom, EC, and you can compare it to this diagram over here. D is up here, which is the top, and then M I'll put here. M is the same M as that you see on the question, and H is here, the same H. And let's draw those lines here. So we got that line, and then this line. And this is the P, because P is the point that is the intersection between EH and MC. And then I will put in that K. So this K is the same as that K. Now, according to our fact up here, where is it? Yeah, this guy. We have that this KD is equal to 5 KP, because KP over KD is equal to 1 over 5. So that is true in this kind of scenario where you've got a triangle where you have the ratios of 2 to 1. So MD was, say, 2x, and ME is x, and then DH was, say, 2y, and HC is y. And that's all explained in the question. If you draw a triangle like that and then draw the two lines like I did, MC and EH, and their intersection point is P, then the ratio of the heights from KP to KD are in the ratio 1 to 5. So that's a fact, and like I said, I'll show the proof of that. But that's what I wanted to establish in this first. And then, if you look at this guy right here, triangle KPV is similar to triangle KDL, right? So because they're similar, the ratio of the sides will be the same. So PV over DL is the same as KP over KD. And since we have established that KD is equal to 5 KP, we can put 5 KP. So that's really just 1 over 5. So PV over DL is 1 over 5. So for example, if this was X, this is 5X. Or let's use a different letter. If this was Z, this would be 5Z. Okay, we interestingly now have enough to solve the question, believe it or not. And then what they wanted is the ratio of EBCP. Let me just double check that. EBCP, yep, over ABCD. Now, the area of a tetrahedron, or is it area or volume? Yeah, it's volume, yeah. Okay, so the volume of a tetrahedron is 1/3 times the area of the base times the height. So we've got to figure out both of those. So area of base times the height. Okay, well the 1/3 is canceled. For the base, let me talk about that a little bit later. The heights though, EBCP, for EBCP its height is going from the base to P. So it's this guy, it's KP. Right? So for that's it's KP. And then for the big guy, ABCD, it's going from the base to D, so it's KD. And then the area of the base, well, the base for EBCP, let's see where I can draw it. I don't want to mess up the diagrams here. Let's just draw it. Let's draw it here, actually. I think I should be able to draw it there. So the base for the big guy, ABCD, that base is ABC, right? ABC. Now the base for EBCP, that is just EBC, where E is here. But if you remember, E is the midpoint, correct? Let's go back to E is the midpoint of AB. So that basically means that this is just half of the total area of ABC. So the area of the base, if this say is ABC, this will be half of ABC. You got it? So the ABC's cancel, you're just left with a half. And then KP over KD, well KP over KD, we have that ratio right here. Or here even, that KD is 5 KP. So if we have KP here, KD is 5 KP. So then therefore this just reduces to 1/2 over 5, which is 1/2 times 1 over 5, which is 1 over 10. So 1 over 10 is the answer. And now I have to show you the proof for this fact number 1 and fact number 2. So here is the proof of fact number 1. You can read it, and it continues actually. As you can see, very long proof. And the proof of fact number 2 is here, and you can read that as well to understand how we got those facts to help us with the question.